Hi everyone, I'm Dr. Koenig, and today we're talking about rational number addition and subtraction. In this video, we're focusing on not just rational numbers, but specifically fractions. Let's get started. Okay, so we're talking fractions today, and we have to remember first, before we think about negatives and positives, what we need when we're going to add fractions. Now, with addition and subtraction both, for those two operations specifically, we need what's called common denominators. That means these numbers at the bottom, these denominators, need to be the same number. So in order to get them to be the same, we need to multiply both fractions by something. What we multiply might vary, but we have to get that common denominator. So here we're working with 8 and 3, both of which go into 24. So what I'm going to work on is getting those denominators to be the same, and specifically to be 24. Then we can focus on the positives and the negatives and all those things. Now, in order to turn 8 into 24, I need to multiply by 3, which means I will multiply the numerator by 3 as well. Anytime I change the denominator of a fraction, I have to do the same to the numerator. On the second fraction, I'm multiplying by 8, which again means I'm going to multiply the numerator by 8 as well. 2 times 8 is, of course, 16. And now I have fractions with common denominators, and I can add. The only thing that makes this rational numbers video different from any other fraction tutorial is that now I'm dealing with negatives. So remember that when you add fractions, you're really contending with the numerators. The denominator is going to stay the same. So I'm adding negative 15 plus 16, which would get me to positive 1. And when you add, the denominator, again, stays the same. So I end up with 1 over 24. In this question, we're doing a very similar routine, a very similar solving style. However, we've got mixed numbers. And in most, if not all situations, it is helpful to make the mixed number into an improper fraction. So I want to show you that on this example. To convert to an improper fraction, you multiply the whole number by the denominator, and then you add the numerator. So for this example, I'm actually going to ignore the negative entirely. I'll come back to that at the end. For this fraction, 2 times 7 is 14, plus 1 is 15. So the fraction I get has a 15 in the numerator. Now the denominator, when you change it into an improper fraction, should stay the same. So it was 7, and it will continue being 7. And we just have to remember to put that negative back with our fraction after we convert. For the second fraction, we want to do the same thing. This time we don't have a negative to worry about, so it's just slightly easier. I multiply 1 times 2 to get 2, and then I add 1, which gives me 3. And again, my denominator should stay the same, so it is 2. Once you have converted your fractions to improper fractions, then you need to start looking for that common denominator. In this case, 7 and 2 both go into 14, and that's the smallest number I can get, so that's a great common denominator. Now, you don't always have to find the smallest, the least common multiple, but it is easier if you do. So if you can find a multiple and there exists a smaller multiple, I would suggest using that one. In this case, I multiply by 2 on that first fraction, and it gives me negative 30 over 14. And on the second fraction, I'm multiplying by 7, which gives me 21 over 14. Once I'm here, once I've got my common denominators, just like in the last example, I'm really focused on those numerators. That's what I'm solving. My answer should have the same denominator. The denominator doesn't change when you're adding or subtracting. It's the numerator that changes. So I will add negative 30 plus 21, and I'll get negative 9. Now, one thing I didn't address in the last problem is when you're adding and subtracting, when you're multiplying and dividing, when you're working with fractions in general, you should always check to see if your fraction can simplify. The examples we've covered haven't needed to be simplified, but that is often the case. Now, this last example is a little bit different because it gives us giant numbers, which is why I wanted to cover it together. If I were to convert this into improper fractions, if I were to multiply and add, I would get negative 43 fourths plus, again, I would multiply and add and get negative 64 ninths. Now, there's nothing wrong with these numbers except that the common denominator here is 36, and that means I have to multiply by a pretty large number on both And I don't really want to multiply negative 43 by 9 if I can avoid it. So I want to teach you a different strategy for this problem. And that strategy involves keeping the mixed numbers as mixed numbers and getting common denominators from there. So here I have negative 10 and 3/4 plus negative 7 and 1/9. Now my common denominator is still 36, so I'm still multiplying by 9. It's just that I'm not multiplying the whole number, I'm only multiplying the fractional pieces. And although that might seem like it is changing the value of these fractions, it's changing the look of the fractions, but we will still have an equivalent value. So here we have negative 10 and 27/36 plus negative 7 and 4/36. Now this is a great strategy because I'm adding two negatives, which I know means I can add the values and I'll have a negative answer. Now when I add them, I'm adding the pieces that are alike. So I'll add my whole numbers first. Negative 10 plus negative 7 is, of course, negative 17. And then I'll focus on those numerators. I've got 27 plus 4, which is 31, giving me negative 17 and 31/36. Now again, this isn't a strategy I would use on every problem, but I wanted to show you an example where leaving it in mixed number form might help. So fractions aren't all that different once you're including negatives. They still need common denominators. Whether you're adding or subtracting with any fractions, positive or negative, you always need common denominators. Otherwise, you solve like you would with integers. So you just really have to be thinking about, do I add or do I subtract based on the numbers that I'm given and the negatives that I'm given? Hopefully you are leaving this video with some strategies for adding and subtracting positive and negative fractions. I really appreciate you being here, and I hope to see you next time.